Okay, this is page 3 and 4. So number 17 says, if the fourth and ninth term of an arithmetic sequence are -10 and -80 respectively, what are the first three terms in the sequence? Okay, so what this is saying is that I have a sequence of numbers. This is the first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Okay, so second, third, fourth. Okay, they told us the fourth was -10. Fifth, sixth, seventh, eighth, and ninth. Okay, and they told us the ninth is -80. It wants to know what the first three terms are. Well, I have to figure out what the common difference is to figure out what those first three terms are. So how did I get from -10 to -80? Well, to get from -10 to -80, okay, I moved 1, 2, 3, 4, 5 times. Okay, so there's a common difference here, and I need to figure out what that common difference is. Okay, so I know that the difference between these two numbers is 70, and I know that I have a common difference 5 times. I added something 5 times to get all the way up to 80. So I added something, I don't know what it was, to get all the way up to 80. So if I divide by 5, because I know it takes 70 to get there, and I need to know what I added to get to 80. So that's going to give me -14. Okay, because I'm going from -10 to -80, so that has to be negative. I have to be subtracting something each time, or adding a negative. So let's see if that works. So I have -10, and I'm going to add -14. I think that's what it is. All right, so then that's going to give me -24, and I'm going to add -14 again. It's -38. Once you've done that twice, you can press enter the calculator or keep adding. -52, -66, -80. So my difference is -14. Now, that's not even what it asked me. It asked me what the first three terms are. So because I'm going to go this way, okay, from -10, I'm going to subtract -14. So my third term is 4. My third term is 18. And my first term is 32. Okay? So you really have to figure out, the key here is to find out what your common difference is. And once you know your common difference, then you can go, because I'm going to the left, I'm subtracting to get your first three terms. All right, next one says the following sequence is given in recursive form. Okay, remember what we said recursive means, that you have to look at what the previous term is to find the next term. What is the value of the third term? It wants to know the third term. Well, notice in this notation here, they gave me the first term. I know A1 equals 3. But notice that AN, so A sub 2, so the second term equals A sub n minus 1. The previous term, well, the previous term was 3. Okay, so this right here is all together. So instead of A sub n minus 1, I'm going to put 3 in there, times 2. Notice this is a geometric. They already gave us the formula, but if you look at your formula sheet, we're looking at this right here. Okay? All right, so this is going to equal 6. But I want to know A sub 3. Well, remember that the formula says the previous term, well, the previous term now is 6 times 2, which is 12. So the third term in the sequence. So that's the difference between recursive and explicit. Recursive, it depends on the previous term, so you're going to have to work out every term in the sequence in order to answer the question, whatever value that it's looking for. All right, let's do another one. It says, write the first 4 terms of the sequence defined in the recursive formula. Okay, so we're doing recursive again, but notice this is arithmetic, okay, because it looks like this. So they give us a sub 1, so a sub 1 equals -1, and then a sub 2, okay, so this is my formula, but remember this piece right here means previous term. So I'm going to have 4 times, my previous term was -1 minus 5. So 4 times -1 minus 5. Oops, 4 times -1 minus 5 is -9. Okay, and it wants to know the first 4 terms, so I got to keep going. A sub 3. Okay, so I have 4 times the previous term, which is -9, minus 5. So 4 times -9 minus 5 gives me -41. Okay, and then a sub 4 said first 4 terms, 4 times the previous term, which is -41, minus 5. -169. Okay. So again, the difference is the term, the nth term, a sub 4, I can't just substitute 4 in, okay, because it's the 4th term. In this case, when it's recursive, I have to look at the previous term. Okay, let's look at another one. The following sequence is given in recursive form. What is the value of the 3rd term? So we're looking for the 3rd term again. Okay, I've already set it up for me. So A1 equals 8. A2 equals 3 times the previous term plus 2. 3 times 8 plus 2. Oops, 3 times 8 plus 2 is 26. And it wants to know the 3rd term. So I have, and don't forget the a sub 1, they gave you the 1st term. So the 3rd term is this one we're working out now. 3 times the previous term, which is 26, plus 2. 80. So the 3rd value of the 3rd term is 80. All right, next, what is the sum of the first 3 terms in the arithmetic series? 2, -5, -12, -18. So it says, what is the sum? So you need to get your formula sheet out. What is the sum of the first 13 terms? And they tell you that it's an arithmetic series. So I need sum. I'm going to use this one or this one. Okay, well, you are going to make a determination based on what you have. So let's look what we have. We know that n equals 13. And we know that a sub 1 equals 2. All right, so for this particular one, we need n, a sub 1, and a sub n. Well, a sub n in this case means the last term. I don't have the last term. So let's look at the next one. I have n, a sub 1, n, and the common difference. So really you could use either of these. I am going to choose this one, okay, because either I have to find the common difference, which I don't know right now, or I have to find a sub n, which is the last term. This formula is simpler, so this is the one I'm going to use, so I'm going to find a sub n. So let's write this formula down. We're going to use this one, the sum n over 2 times a1 plus an. It's not incorrect to use the other formula. I'm just making a choice to use the first one. Okay, so they want to know s sub 13. N is 13 over 2 times a sub 1, which is 2 plus a sub n. All right, so that's the part I don't know. All right, I want the last term. Well, the last term, okay, I can actually figure out what the last term is by using this formula right here. So I'm going to use a sub 13 equals a sub 1 which is the first term, plus n, which we said was 13 minus 1, times d, which is the common difference. So we've got to figure out what am I adding each time, and I'm adding negative 3 each time. No, sorry. This is positive 2 to negative 5, so I'm adding negative 7 each time, not 3. Negative 7 each time. So just make sure that works. 2 plus negative 7 plus negative 7. So that works. So it's negative 7. So times negative 7. All right, so 2 plus 13 minus 1 times negative 7 is negative 82. Okay, so the last term is negative 82. So then I'm going to plug that into here, negative 82, because that's what I was missing. So a sub n was negative 82. Now I can solve. Alpha y equals 13 over 2 times 2, times 2 plus negative 82. So negative 5,280. It's the sum of the first 13 terms. All right, next is the sum of the first 18 terms. All right, so same process here. Let's use the other formula for this one, because again, it doesn't matter which one you use. So I know I have sum, and it's arithmetic again. So I have to use one of these. So in this case, I'm going to use this one. Sn equals n over 2 times 2 times a1 plus n minus 1 times d. Okay, so n equals 18. It says sum, so that's why I know to use this formula. Again, you could use the other one, but whatever makes you happy. Okay. And then what else do I need? I need a1, so the first term, which is 4, and I need the common difference. So the common difference, what am I adding each time? So I go 4 to negative 5. So it looks like I'm adding negative 9. But remember the trick I told you, you could go from the other way. I could do negative 5 minus 4. That is negative 9. So 4 plus negative 9 plus negative 9. So that's correct. So my common difference is negative 9. So let's plug in. N is 18 over 2 times 2 times 4 plus 18 minus 1 times negative 9. I'm going to plug that whole thing in to the calculator. Alpha y equals 18 over 2 times 2 times 4 plus 18 minus 1 times negative 9. I retyped that, then I had 18 over 22, so that doesn't make sense. So 18 over 2 times 2 times 4 plus 18 minus 1 times negative 9 gives me negative 1,305. So the sum of the first 18 terms is negative 1,305. Okay, does the geometric series converge or diverge if a sub 1 equals negative 3, r equals 4, and explain your reasoning? Okay, so this is what we talked about before on our formula sheet. So to converge or diverge. So this example here, okay, is an infinite geometric series, and we say that it converges if r is less than 1. Okay, so if the absolute value of r is less than 1, and then it converges. However, if the absolute value of r is greater than 1, then it diverges. So for this example, r equals 4, so the absolute value of 4 is greater than 1, so this example diverges. So you've got to be able to figure out what r is, or if they give you r, be able to say whether it diverges or it converges. If it converges, then you can use this formula here, and we're going to do some of those in a few minutes, okay? All right, next one. What is the 16th term of the arithmetic sequence with the first term of 6 and a common difference of 3? Okay, so it's not asking for sum. It's not anything saying anything about recursive, which means if I'm arithmetic, I'm going to use this guy right here. So a sub n equals a1 plus n minus 1 times d. a1, first term. Oh, they told me first term is 6. Common difference. That's my d. And then n says the 16th term. Now I can just plug it in. So 6 plus n minus 1 times 3. So the 16th term, 16 plus 16 minus 1 times 3. It's 51. Okay. All right, let's look at the next one. Suppose you're building 12 steps with 8 concrete blocks in the top step and 96 blocks in the bottom step. Okay, so I'm going to build steps, and the steps kind of go like this. I'm the world's worst artist. Okay, so I have 8 blocks on the top step. And then I have all the way down 96 on the last. So I have 8, and then on the very last, I have 96. Oops. So something's happening in here, 96. Okay? And then it says you have a total of 12 steps. So there's 12 total in all of these. If the number of blocks in each step forms an arithmetic sequence, find the total number of concrete blocks needed to build the steps. So the total number, okay, total number means sum. So they want to know the sum of the concrete steps. All right, so we need sum, and it says that it's an arithmetic sequence. All right, so let's see what information we have. We know we have to do with one of these two formulas because we're dealing with sum and arithmetic. So I have 12 steps. Okay, so that means that n equals 12. It has 8 at the top and 96 at the bottom. So a1 equals 8, and then an, or a12, equals 96. Okay, so then if I look to see with the information I have, this one is the most appropriate formula. So the sum of the 12 steps equals 12 divided by 2 over a1, which is 8, and a sub n, which is the last step of 96. All right, so let's take a look. So we're going to put that in the calculator. Alpha y equals 12 over 2 times 8 plus 96. So there's a total of 624 blocks. All right, last page. It says identify if convergent or divergent. If convergent, find the sum of all the terms in the infinite series given the formula. Okay, given the formula, they didn't give it to us, but we just talked about this. We know that this is the infinite geometric series, the sum of the infinite geometric series. So we know that if it is convergent, okay, if it is convergent, then the absolute value of r is less than 1, and that means that we will use the formula a1 over 1 minus r. If it is divergent, okay, absolute value of r is greater than 1, then all you do is write divergent. You cannot use the formula. Okay? All right, let's look at the first one. So kind of the key to this is figuring out what r is. So r, it's geometric. I know I'm multiplying something each time. So for this one, I'm multiplying. How do I get 16 to 14? All right. Well, you might say I divide by 4, but remember you have to say what are you multiplying each time. So I'm going to multiply times 1/4. All right, and there's a trick to this too. So if you don't see what you're multiplying each time, go from left to right. Do 4 divided by 16. Math, enter, enter. That'll tell you what you're multiplying. So my R equals 1/4. So the absolute value of 1/4 is 1/4. Okay, so is 1/4 less than 1? Yes, that means that it's convergent, which means that I can find the sum. So I say I want to know what a sub 1 is, which is 16. I already know my R, so I can plug into the formula. 16 over 1 minus 1/4. Put that right into the calculator. This is S. 6 alpha y equals 16 over 1 minus 1/4. And please be careful with this. My suggestion is just to put it directly into the calculator. So that gives me 64 over 3. So it converges onto 64 over 3. All right, let's look at the next one. All right, this one looks, I don't know what's going on here. So I'm going to do the trick. I'm going to go from the second term to the first term. And I'm going to say, I'm looking for what I'm multiplying each time. So if I said 1 over 3, and because I'm going from the second term to the first term, I could say divided by 1. I'm multiplying times 1 over 3 each time, times 1 over 3. And then you can check that. So 1 over 3 times 1 over 3 gives me my third term, which is 1 over 9. So R equals 1/3. So is 1/3 the absolute value of 1/3 less than 1? Yes, it is. So I know that this converges. All right, which means I can use my formula. I already have R, a sub 1 equals 1, so I can plug into my formula. So I have 1 over 1 minus 1/3. I'm going to plug that in. 1 over 1 minus, alpha y equals 1 over 1 minus 1/3. So 3 over 2. All right, next, what am I multiplying each time? Well, it looks like I'm multiplying times 2, but 100 times 2 times 2. So 4, I am multiplying times 2, so R equals 2. Is the absolute value of 2 less than 1? Nope. Is the absolute value of 2 greater than 1? So R is greater than 1, which means it's divergent. And that's all you have to do is write divergent. Because you can't find the sum of something that's divergent. All right, next one. What's happening each time? Ooh, I don't know. So I'm going to use my trick. I'm going to go from second to third term. I'm sorry, second to first term. 3 divided by 5. So I'm multiplying 3 over 5 each time. Let's try again. So times, multiply that times 3. Gives me 9 over 5. So my R equals 3 over 5. Is 3 over 5, the absolute value of 3 over 5 less than 1? It is. So I can use my formula. A sub 1, which is my first term, is 5. And then I'm back up here to use this formula. 5 over 1 minus 3 over 5. Plug that in the calculator. 5 over 1 minus 3 over 5, which is 25 over 2. So it converges on 25 over 2. All right. Find the explicit formula for the arithmetic sequence where a1 equals -3 and d equals 14. So it's actually not asking you to solve anything. All it's asking you to do is find the formula. So arithmetic, we said the first one was explicit. They give you a1 and d, so I know I'm going to use the formula an equals a1 plus n minus 1 times d. And all you're going to do is substitute. An equals -3 plus n minus 1 times 14. Then we can make this look pretty. Negative 3 plus 14n minus 14. And then negative 3 plus negative 14 is negative 17. So a sub n equals 14n minus 17. So that would be your final answer. Alright, next one says find the explicit formula for the geometric sequence. A sub 1 equals 15 and r equals negative 2. So we're geometric, explicit. So I'm going to use an equals a1 times r to the power of n minus 1. Substitute in an equals 15 times negative 2 to the power of n minus 1. I can't simplify that because remember we talked about order of operations, exponents before multiplication, so we have to leave it just like that. Okay, given the arithmetic sequence, 3, 8, 13, 78, which, 78 is which term in the sequence. So 78 is which term for the sequence. So they want to know what n is. What is it, the 5th term? Is it the 9th term? Is it the 100th term? Okay, so let's look at the stuff that we have. We know that a1 equals 3. I know I can find my common difference. Okay, so my common difference is going to be, what am I adding each time? It looks like I'm adding 5. So 3 plus 5 is 8. 8 plus 5 is 13. So my common difference is 5. All right, so let's see what formula we can use. Okay, so for this particular one, they want to know what n is. I've got a1, I've got a sub n, okay, because that's the 78. I know what d is, and then I can solve for n. Okay, so a sub n equals 78, and then I know that I can use this formula. an equals a sub 1 plus n minus 1. All right, so an equals 78. So 78 equals 3 plus, n is what I'm solving for, minus 1 times d, which we said was 5. Okay, so I've got 78 equals 3 plus 5n minus 5. 78 equals 5n minus 2. Add 2 both sides. So that's 80 equals 5n divided by 5. N equals 16. So 78 is the 16th term in this sequence. So 78 is the 16th term in the sequence. All right, last two. Find the two geometric means between 2 and 28. Okay, so remember that when you have a geometric sequence, it's saying, what am I multiplying to get from the first term to the second term? What am I multiplying the second to third term? What am I multiplying third to fourth? And it has to be the same. And we call that the common ratio. Okay, so I'm looking for the common ratio. Okay, that's going to get me from 2 to 28 with 2 terms in between. Okay, so, well, I need to know what is, because we're looking at geometric mean, I need to know, well, how do they get from 2 to 28? Or sorry, 2 to 128. So 128 divided by 2, it gives me 64. Okay, because I know that I have 2 terms in between there. Now, I know that I have my ratio, okay? I'm multiplying that ratio 3 times. Oops. R times R times R to get to 128. Should be an R. And I know that equals 64. I'm dividing that 64 in between here, okay, evenly, because it has to be the same. It has to be a common ratio. Well, R times R times R is R cubed. Well, so if I take the cube root of both sides, I find that r equals 4. So 2 times 4 is 8. 8 times 4 is 32. And 32 times 4 is 128. So 4 is my common ratio. Okay. All right, and then we could do the same thing with the arithmetic mean. There's no formulas for this. So I'm looking, what did I add here? 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 Okay, I'm adding something 1, 2, 3, 4 times. So d plus d plus d plus d is 4d, okay? Because that has to be split evenly because it's a common difference, okay? And then I need to find out, well, how did I get from 3 to 31? Well, 31 minus 3, okay, is going to give me 28. So I've got to divide that evenly between these 4, I'd like to call them jumps. So 4d equals 28 divided by 4. So d equals 7. Well, let's see if that works. So 3 plus 7 is 10. Plus 7 is 17. Plus 7 is 24. Plus 7 is 31. So I'm adding 7 every time. Okay, and that's it. Good luck on your test.